Hello guys, and welcome to AI Sciences. Today we are going to learn how to build a recommendation engine with PyTorch. We'll be starting with an introduction to recommendation systems and PyTorch, which is a very important library in Python that is used to train deep learning models. We'll also end up with hands-on practice and build it on a real-world dataset. I am your instructor Abdullah Aziz, and this is AI Sciences. Alright, so recommendation systems are very important nowadays, and they are used to find ratings or preferences to users based on previous data. Recommendation systems can be used to recommend you movies, to recommend you food based on your previous history or your likes and dislikes. So we'll get into it. We'll look at how the data works and how PyTorch is used to train and build those models. So let's get started. We'll start with importing libraries and dependencies. We'll be using Google Collaborative for this process since it is very easy to use and has lots of additional features. We'll also do the data loading and preparing. Then we'll build the model and its loss function. And then we're going to test our outputs and perform some evaluations. So let's get started with programming this recommendation system. Alright, so I have already imported all the important libraries in PyTorch that we are going to use for this recommendation system. So let me just run these cells and we'll get to their details once we are using them. So we'll be choosing the random state equals 1, which means that the data that we are going to use will be of a certain random state, right? So it will be always the same once we train our models, right? And now we're going to download this data from a URL that is provided, right? And we're going to convert it into CSV format here, where you see this statics and the .csv, which is determining the format of the file, whereas the user ID, movie ID, rating and timestamps are actually the names of the columns. So we'll just run this bit, and this is to prepare our dataset, and we are just going to check if it's working fine. So we are going to take this archive URL, which is some URL, right? And it says we put this F in front of it because it's the file that tells us about the location and the presence of dataset, right? So now we are going to give this group lens dataset, right? We're going to perform this import of dataset from a particular website, and we're going to use the movie lens dataset, which is full of different movies and their ratings according to users, right? So this is important. Now we have given its path, and we're going to use the download path for this variable, and it's going to be path.home, and we're going to concatenate another string to it, which is the data string, and we add this plus sign here, this slash sign here, to make sure it is concatenated with the already existing path, right? And we have movie lens at the end of it. So we just run this, and the dataset has been downloaded to this particular path. Now we do the try. We use the try download function that we've already built, right? And it's going to take the same URL. So let me just write it here, and the download path. So you just combine all the variables that are necessary to provide this. Alright, so it says that there's this issue with the path, and just let me look into it. Files.grouplens.org, datasets movie lens, and then there is path.home movie lens, right? So alright, so it says that there is this extra bit of s here. We're going to look into this error. Alright, so path.home, and we provide the functionalities, all the important functionalities, and it is files.grouplens.org. And we just so if we just comment this out, I think this will be fine. Alright, so we use this instead and do the download path. Right, so the data has been downloaded to this particular path. If we go into our drive that has been already uploaded here, if we go into the root function here, we have data and we have movie lens, right? It's in this path already here. So we have movies.dat, ratings.dat, and users.dat. So we have 3 files with us here, which means that the data has been downloaded successfully, right? So now we're going to use this command that is going to list all the important files in this particular folder, right? So we are going to do download path, right? And this is going to return us the place where there's 4 total files, right? And we have all the lists available with us right now. So now we're going to extract movies and rate their ratings, right, from this data, and we're going to use the read data function, where we have the download path already available with us, and we're going to add some further strings to give it a proper path, right? So now this is going to load is LOAD, right? So this is going to store ratings into this variable, and movies and the information or the data about movies into this variable. So we have ratings and movies with us. Now we have to display this piece of data. We just do the ratings.head and movies.head function for this particular purpose. Since these are data frames, we have 4 columns in this data frame, which is ratings. So there's user ID, there's movie IDs, ratings, and the timestamps. Some of these columns are very useful for us, whereas some of them don't make much sense. For example, timestamp is of no importance here. Whereas the movie's head has the movie ID, their title, and genres, right? So what we are going to do is we're going to combine this data set on the basis of movie ID, since it is the common column in ratings as well as movies. So we are going to make a huge table out of it, and it is going to be part of our data preprocessing. Right, so now we're going to move on to data preparation, and we have this function here that is going to perform a group by on user ID and ratings, right? And then it's going to take all the unique users and attach their ratings according to movie IDs. At the end, it's going to return us the number of users and the number of movies, as well as it's going to index our users and movie indexes. So we run this piece of code here, and we're going to look at the outputs of this particular function, and hopefully it's going to be, so x and y are going to tell us about are going to split the data set into train and test. And then we have this variable that is the indexes of movies, and we're going to use this create dataset function. Create dataset, yeah. So, and we're going to pass it ratings, right? So this is going to give us all the necessary information, and we'll have users and their corresponding movies. I think the n variable here is the number of users, right? So let's just add users here. It's going to be users n, right? So this will be so there's 6040 different users, which validates according to the original dataset, right? And then we'll look at the number of movies, and with that is m here. This is just to verify our function if it has worked correctly. So there's 706 total movies, right? And we can also do the print out the data frame shapes. So we have X shape, which is the data set shape, right? So we just print it here, and we have this much data with us, right? Alright, so let's get into the reviews iterator. This was for the creating our ratings. Now we have this function here. What it does is it takes in all this information. We provided the batch size, we provided shuffle, we keep it true, and all of this x and y, this x and y that we have calculated here, that we have found here, is going to be used in this particular class, right? X and y is actually the training test and their labels. So labels are targets that we have to match according to our data set, right? And so we just run this class function here, and we have all of this is ready right now. Our data set has been transformed into different classes. We define the batches, and for x and y batch we also make this function here that is going to divide the dataset into manageable pieces of code, right? Next we move on to embeddings, and now embeddings are important, and they provide information. They convert our information into useful variables, right? So embeddings play an important part when we're dealing with natural language processing tasks, right? Now embeddings turn the dataset into something that is more understandable by the deep learning model. It converts all the data points into some numeric numbers, right? And it has this history where it keeps track of what numeric number determines what corresponding natural language processing datasets. So we do this embedding net. We use a deep learning model that is going to perform embeddings, and it is going to it takes all these arguments or parameters as input, where n users is the number of unique users, and movies determines the n number of unique movies that we have. Then n factor is the number of columns in the entire embedding, right? So it reduces the columns into 50, whereas in some cases it's going to increase it to 50 where it was less. Then we have the embedding dropout, which is set to 0.02. Hidden layers is going to be 10, and the dropout for the machine learning or deep learning model is also set to 0.2. Now these dropout actually help us design a more general model. General models are deep learning models that perform good on unseen data, right? Any model could memorize the training data set and produce good results. But a good training model is one that performs great on unseen data set. So dropout helps us, program good general models. So we're going to run this piece of code, and then we have all the functions readily available for us. We perform this embedding net function, and it returns this particular deep learning model. Now we give it some real data set, we give it more hidden layers, we'll pass a list to it, and then we pass some dropout, different values for dropouts and hidden layers, and factors is the same, right? So we have this bigger deep learning model that is more diverse. Now we have this cyclic learning rate, which the purpose of this is to perform good early stopping learning rates, and it is it inherits the LR scheduler class from PyTorch library, and it was built by the fast AI team, and we are just importing it here and using it to our purpose. Then we have the the triangular function, which takes the learning rate and performs and takes out the best learning rate. It calculates the learning rate, that is it tries different learning rates to the data model and returns the best scheduler. Similarly, we have cosine functions with us, and this cosine function determines the similarity between our training model and the testing model, right? Now cosine similarity has to be higher. For our case, a higher cosine similarity means a good learning has taken place. Then we have the we're going to plot the learning rate, and we're going to schedule it for some values. Now the training loop has been this code will be provided to you in the description, this a link to the notebook, and you can just go ahead and try different values for it for yourself. Now we have split our data set into train and test, which means the validation part. 80% of the data set is kept for training, whereas 20% is left out for validation. We put all these data sets into a dictionary for key values, train and validation, and we also store their sizes. Then we perform this min-max function, which is going to take the minimum and maximum of our ratings. 1 is the minimum rating, whereas 5 is the maximum rating. We get this class of net, the model for us, and we go on to training here. Now the net.to device is actually the line that is converting our model into the GPU format. And for learning, we define two phases, training and validation. We start with loss 0 and start with batches equal 0, whereas batches are always kept in data sets, right? And we perform all the optimization, and we do the training here. We take the loss and we do the back propagation point at this point. Then we store the loss at every point, and for each epoch we print the loss here. Now as you see, the loss is decreasing for both training and validation. This means that training is taking place and a good model is being learned here. Alright, so now we're going to test our model the one that is training right now. And while it's training, we can go ahead and write its code. So we have two data sets here with us, and we are going to take for each batch in training as well as in we're going to turn on the shuffle for it, and we're going to say shuffle equal false at this point, and we're going to give ps equal ps function to it. Now for this loop, we are going to get the x batch and the y for this batch, right? And we take this and we convert it to device. Convert the trained model into device, and we're going to do that for every b in batch. So that is where most of the, and then we get the outputs for our model. We do the net and we give it some input at this point. So we're going to take the x batch, give it all the rows and columns, and then we're going to do the x batch for all the rows here, right? And we're going to perform min max at this point. So then we are going to get the ground truth dot extend y batch dot to list. Yes. And for predictions, we are going to store our predictions at this point, and we're going to do outputs dot to list, and then we are going to save the ground truth here, and we're going to make it into a numpy array. Pass ground truth dot rebel. Now rebel is going to flatten this array, and we also do the same for predictions equal. We can copy this line and paste it over here. We take the predictions and do the same things with it. So for the loss, we are going to calculate the we are going to go ahead and find the loss here. We're going to take the square root, which is the mean square root of for predictions and ground truth. So we are going to take the mean of predictions minus ground truth. So this will return us the root mean square error for our model. This is based on inferencing, and we can test it out for different values. So the training has already been done here, and all of this this notebook and important links will be provided to you in the description. And if you like our content, please don't forget to subscribe our YouTube channel, share the YouTube videos as much as possible, and keep on learning. So see you in the next video.